NASA's Kennedy Space Center in Florida, you are watching live coverage of the SpaceX CRS-11 launch, the 11th SpaceX commercial resupply services mission for NASA to the International Space Station. Good afternoon, I'm Mike Curie along with Tori McClendon.
Thanks, Mike.
Tori, there are lots of folks, including some that we just saw at the Banana Creek viewing site, who are anxious for launch today.
Yes, there are, and we're excited as well. So welcome back to the second launch attempt of the Falcon 9 rocket and Dragon spacecraft, SpaceX CRS-11. The weather today is looking much better than it did on Thursday. Mike, can you give us an update?
Yeah, you bet. As you can see here, we have some really good news. The probability of violating launch weather constraints has improved to just 10%. So the way we like to say it is we have a 90% go forecast. Winds from the east-southeast, 10 to 15 miles an hour, 82-degree temperature, but there's nothing within the 10 nautical mile range that we have to have any concerns with today. Launch Weather Officer Mike McAleenan has briefed Launch Director Mike Taylor and told him that he expects through the T0 count that we should have no issues with any launch commit criteria.
Great. So our first launch attempt on Thursday was scrubbed when a thunderstorm formed within 10 nautical miles of the launch pad and generated lightning within the last 30 minutes of the countdown.
But luckily, that does not look like it's going to happen to us today. For our launch at 5:07 and 38 seconds p.m. Eastern Daylight Time from Kennedy Space Center's Launch Pad 39A. At the time of launch, the International Space Station, which is the destination of the rocket, will be flying 254 statute miles above Oman in the Persian Gulf region.
Coming up, we'll provide you with an update on what this mission means to NASA and SpaceX. We'll hear from Kennedy Space Center Director Bob Cabana and SpaceX Vice President of Build and Flight Reliability, Hans Koenigsmann, and we'll examine the science and experiments packed inside the refurbished Dragon spacecraft for their trip to the space station. That's right, for the first time, the weld structure and most of the components of a previously flown Dragon spacecraft will fly again on this mission. The Dragon spacecraft previously flew on SpaceX CRS-4 in September of 2014 during Space Station Expedition 41. Now the Dragon is ready to fly again.
And on the countdown, everything has progressed well so far on its way to launching Dragon today. A collision avoidance coordination with the Eastern Range was performed earlier, and there are no collision avoidance issues to worry about. A checkout of the autonomous flight termination system was performed. Loading of RP-1 fuel began on time at T-minus 70 minutes, or 3:57 p.m. Loading of liquid oxygen began at T-minus 45 minutes, or 4:22 p.m. Eastern Time. And the Eastern Range confirms it is go for launch and landing of the Falcon 9 first stage at nearby Cape Canaveral Air Force Station Landing Zone 1.
To give you some interesting facts about this mission, this is the 11th contracted cargo resupply mission for SpaceX with NASA to the International Space Station. This launch holds significance as the 100th launch from Pad 39A. Previous launches include 11 Apollo missions, launch of the unmanned Skylab in 1973, 82 space shuttle flights, and 5 SpaceX launches. This is also the 27th launch from Pad 39A to the space station, including 25 shuttle launches and SpaceX CRS-10, which was the first commercial launch from Pad A in February. CRS-11 will be the 6th launch for SpaceX from Launch Pad 39A. The Dragon spacecraft will deliver nearly 6,000 pounds of experiments, supplies, and hardware to the orbiting laboratory, scheduled to arrive 2 days after launch. These critical materials will support dozens of the more than 250 science and experiments that will occur during Expeditions 52 and 53. This includes investigations that will test a new solar panel design, study neutron stars, osteoporosis, and spaceflight effects on the cardiovascular system.
After launch today, Falcon 9's 2 stages will propel the Dragon to a speed of 17,500 miles per hour in about 9 minutes, starting a journey that will culminate in a rendezvous with the space station on Monday. While in the vicinity of the space station, the astronauts aboard will be in direct communication with Dragon, monitoring the spacecraft, issuing spacecraft commands, and after completing checkout procedures, Dragon will receive final approval to gradually approach the station from the radial direction toward the Earth. As it approaches within a few meters, U.S. astronaut Jack Fisher will reach out and grapple it with the station's robot arm, and then controllers at Mission Control in Houston will operate the arm aboard the station to move it into position at the berthing port where it will be locked in place. Dragon will be staying at the station until July 2nd, when it will return to Earth packed with research items and parachute to a safe landing in the Pacific Ocean. Well, there are very few people with the insight and experience of our next guest. After all, he commanded the very first space shuttle mission to the International Space Station, the first assembly mission.
So what does a veteran astronaut and leader of the Kennedy Space Center think about the launch today? Well, let's check in with Eric Matthews, who's standing by.
Hey, thanks, Tori. It's a great day to be alive, an exciting time here at Kennedy Space Center as I stand here with the Kennedy Space Center Center Director, Mr. Robert Cabana here at OSB2. Sir, how are you doing today?
I'm doing great, Derek. What an awesome afternoon for a launch. Everything's looking good, man. The weather's coming together. The vehicle's good. I think we're going to get off this afternoon.
Yeah, we're very excited out here, sir. Just a couple of questions for you while I got you here. Can you give me your future vision for Kennedy Space Center, please?
Well, I think we've pretty much got our vision in place. Now we need to ensure that everything's really cemented in place. I got a few more agreements I'd like to get with a couple other commercial companies, but right now what I want to see happen is I want to see commercial crew flying to the International Space Station with SpaceX and Boeing, so we don't have to rely on our Russian partners anymore. And I want to make sure that we've got everything absolutely ready to support SLS and Orion. I don't want KSC to be the reason we don't launch on time, and so far we're looking good. You know, we're gonna be ready here at the Kennedy Space Center. I'd really like to see that big rocket launch from here one day and give us that ability to explore beyond planet Earth again.
Yeah, I think we're all excited about deep space exploration, sir. One other question for you. This is the 100th launch off of Pad 39A. What does this milestone say about Kennedy Space Center?
Well, I think that's pretty cool. I mean, first off, we stand on the shoulders of giants here. When you look at the vehicle assembly building, you know, they let the contract for that back in February of 1962. And look how it supported Apollo. We were able to transition it to support, you know, the space shuttle for 30 years. Now we're transitioning again. Great vision. The same with those launch pads out there. You know, in the agreement that we have with SpaceX, a 20-year use agreement, I mean, that pad would have sat out there and rusted away in the salt air. Instead, you know, we've already had 5 commercial launches off it. We're supporting cargo to the International Space Station. For NASA, we're going to be flying crews off that pad to the International Space Station. What a great use for that asset. So it's showing the flexibility, what a great vision that they had in the past, and how we have transitioned from Apollo to the shuttle and now to commercial operations off Pad A, and out on Pad B, you know, we're going to be flying SLS and Orion and maybe a couple more rockets too if we can work it out.
Mr. Cabana, I really appreciate your time. Thanks for coming out here today and enjoying this launch with us.
My pleasure, Derek. It's just great to be part of this NASA team. I can't think of anywhere else I would rather be than right here at the Kennedy Space Center today, watching CRS-11 on a Falcon 9 go to the International Space Station.
I'm going to have to second that, sir.
Amen.
All right, I'm going to send it back to Mike and Tori back at the press site. Mike and Tori, take it away.
Thanks, Derek. So this is a NASA mission to the space station, but it's contracted through SpaceX. So Mike, can you tell us how that works?
Yeah, and as Mr. Cabana alluded to, it is a contract agreement that NASA has with SpaceX. This is the 11th of up to 20 missions to the International Space Station that SpaceX will fly for NASA under the so-called CRS contract. In January 2016, NASA announced that the Falcon 9 launch vehicle and Dragon spacecraft were selected to resupply the station through 2024 as part of a second commercial resupply services contract award. Under these CRS contracts, SpaceX has restored America's capability to deliver and return significant amounts of cargo, including live plants and animals, to and from the orbiting laboratory.
You're looking at a live view of the Falcon 9 rocket on Pad 39A. Falcon 9 topped with Dragon is 229.6 feet tall and 12 feet in diameter. Its 9 first-stage Merlin engines generate more than 1.7 million pounds of thrust at liftoff, rising to more than 1.8 million pounds of thrust as Falcon 9 climbs through the atmosphere. Dragon is 26.6 feet tall and 12 feet in diameter. The trunk is 9.2 feet tall. With the solar arrays fully extended, it measures 54 feet wide.
Tori, one of the interesting things on this flight, and as we progress into the future with our commercial space endeavors, the Autonomous Flight Termination System, which you'll hear referred to as AFTS, autonomously makes flight termination decisions using redundant computers that track the launch vehicle while using global positioning system and inertial navigation system along with configurable software-based rules, so that if a rocket goes off course, potentially endangering the public, the AFTS would issue a command to terminate the flight, which is something that's relatively new. Here at KSC, folks worked with the Air Force and some commercial partners on it, and after formal testing was completed, the AFTS flight software, which is called Core Autonomous Safety Software, or CAS, was approved for operational use by both the eastern and western launch ranges and is in use today for this launch of the SpaceX Falcon 9.
So we know this mission is dedicated to restocking the supplies on the station, but also just as important, it brings brand new science and research to supplement all the science that's already on board.
That's right. Dragon is carrying critical materials to directly support dozens of the more than 250 experiments aboard that will be performed by the Expedition 52 and 53 astronauts and cosmonauts. And for more on that, let's check in with Amanda Griffin. Amanda?
Thanks, Mike. And boy, what a difference 2 days makes. It is absolutely gorgeous out here today. So in the Dragon spacecraft, there are both a pressurized and unpressurized section. This allows for a wide array of different payloads and experiments to be sent to the space station. This today loaded in the unpressurized section are some new technologies that we will be testing in space. NICER, which stands for Neutron Star Interior Composition Explorer, is an instrument that will measure neutron stars and test technology using pulsars as navigation beacons. MUSES, or Multiple User System for Earth Sensing, is an Earth viewing imaging platform created by Teledyne Brown. The platform will house high-resolution digital cameras and hyperspectral imagers. And ROSA is the Rollout Solar Array. It is a new type of solar panel that rolls open in space like a party favor and is more compact than current rigid panel designs. And in the pressurized section of the Dragon spacecraft, it allows us to store more sensitive types of experiments, like the fruit fly experiment. And here to tell us a little more about that today is Dr. Karen O'Core. She's a co-investigator of the fruit fly experiment, so thank you so much for being with us.
It's a pleasure to be here. Thank you.
So I understand that you're going to study the effects of microgravity on the hearts of fruit flies. So my first question is, why on earth fruit flies?
That's a really good question. And first of all, because flies do have hearts. And second of all, their hearts are functioning very much like human hearts, surprisingly. They have many of the same genes and proteins, components that make up the heart muscle cells. In addition, they have about the same heartbeat rate as ours. And that's an important thing because mice, for example, beat about 10 times faster. Their hearts beat about 10 times faster than ours. And that makes them just enough different that some issues are difficult to study. The other reason is they're small. So I have here a self-contained unit. These are what we are sending up on the Dragon. We're going to send 90 of these vials. They contain food on the bottom, and you can see the flies inside. And if you roll your video...
We have a tape, I think we have. Show a little bit more of Dr. O'Core and her work.
So here you're looking at a close-up of the fruit flies. We have thousands of these vials in our lab, and they contain many, many flies that we can study and look at the effects on hearts as well as other aspects of fly biology. And here I'm dissecting the fly heart. We removed the guts from the fly. That's a technical term. And we then can record that you'll see just shortly. We can record using high-speed video cameras. We can record the heart beating. This is a picture of the heart beating, a close-up. And we have computer programs that allow us to analyze in great detail the function in these hearts.
That is amazing that you can get so detailed in there. And so I have with me one of your vented fly boxes. So you were all prepared to go on Thursday.
We were.
So what did you have to do to reset all your fruit flies for today?
We were so excited, and then after the scrub, we had to brush it off. We went and got some dinner and went back to the lab and started all over again. We started collecting flies and have been doing that for the last 2 days in order to fill the 6 boxes that they took off the Dragon, brought back to the lab, and we refilled them with fresh flies.
So there's 6 of these total.
There are 6 of these that are going up, yes.
And you have eggs and adult flies in there?
That's correct. We're sending up just eggs so that we know the age of the flies when they come back. That's because we know their hearts begin to show dysfunction as they get older. So we want to make sure we know exactly the age we're looking at. And so we're sending up 4 boxes with about 50 to 100 eggs in each vial and 15 vials per box. So that's thousands of eggs.
That's a lot of test subjects.
It's a lot of subjects we hope to get back. And then we'll send up 2 boxes with adults that will lay eggs up on the ISS.
And what's the purpose of all of this? Like, what do you hope to learn for both astronauts and maybe here on Earth?
Right. We want to understand the effects of microgravity for all the people who are going to be exploring low Earth orbit and eventually Mars and the Moon. We want to know what happens to the heart when they spend extended periods of time in microgravity. Flies age very quickly, so in a few weeks that's equivalent to a couple decades in human terms. So we can get a good idea what's going to happen in response to microgravity to their hearts. But there's real world implications. People who who are confined to bed or are immobilized for whatever reason experience progressive cardiac dysfunction. And we should gain some insights into how to treat that by our studies in microgravity.
That's outstanding. I can't imagine. I never would have thought fruit flies would have garnered all that information for us. So as we can see from the countdown clock, we've got about 21 minutes, and I know this is your first launch.
I'm so excited.
So I'm going to let you go so you can get to your viewing seats and enjoy that. So Mike and Tori, back to you guys.
Thanks, Amanda. So the research going up on this mission is just incredible. This is Falcon launch control at T-minus 20 minutes and counting. So Mike, can you give us an update on the status of today's launch countdown?
Yeah, Tori, everything is going very, very smoothly. You know, typically when you're involved in a launch count, you're listening to a number of loops, they call them, with the flight controllers and launch controllers discussing any potential issues, and everything has been absolutely quiet. Everything has gone by the timeline. Launch Director Mike Taylor has verified the launch and first stage landing danger areas are clear to personnel. The range coordinator has verified the eastern range is go for launch and landing. The Dragon controller has verified that the Dragon launch terminal count auto sequence has started, and Mike McAleenan, our launch weather officer, has continued to apprise the team of any issues. And contrary to what it may look like on your television screen, the clouds are far enough away. There is nothing containing any precipitation in the 10 nautical mile circle. Everything is clear, so weather is definitely go at this time. Tori?
So we're closing in on final activities leading to the launch today at 5:07 and 38 seconds p.m. Eastern Daylight Time. We're looking live at currently at the pad at Launch Complex 39A.
You can see the SpaceX hangar in the foreground there. And now here we are in Hawthorne, California.
Yes, where the team will oversee the Falcon 9 after liftoff, and the Dragon capsule will be on its way to the International Space Station. So now you're looking at Johnson Space Center in Houston, Texas, which is the International Space Station Mission Control team, headed by Flight Director Emily Nelson, awaits today's launch, as do the 3 crew members aboard the station.
That's right. The 3 crew members, Fyodor Yurchikhin, who is the commander, having taken over from Peggy Whitson on Friday. Peggy remains aboard, along with Jack Fisher, who will be operating the robot arm to grapple the Dragon capsule when it makes its close approach to the space station on Monday. Again, beautiful weather today. It looks like that will not be a concern. And at this time, the SpaceX launch control team is not working any technical issues. We're 18 minutes, 20 seconds away from launch.
So Hans Koenigsmann is a SpaceX chief engineer on console in the Launch Control Center today. He is also the SpaceX vice president of flight reliability.
And recently, our Josh Finch of NASA Communications had the chance to talk to Hans about this CRS-11 mission.
Thanks, guys. I'm here with Hans Koenigsmann, Vice President of Build and Flight Readiness at SpaceX. Hans, this is the 7th flight for SpaceX this year, the 6th from Pad A. This is also the 100th flight from Pad 39A here at the Kennedy Space Center. Mm-hmm. Can you tell me what it means for SpaceX to be launching on this mission today?
Well, first, it's a great honor to have the 100th flight from 39A, and then, of course, to supply, in general, resources and cargo to the space station. So that's we really appreciate that at SpaceX, and we know how important it is for NASA and for the ISS to bring those cargo and the science experiments and everything that's in both trunk and Dragon safely up to the station. On top of that, this particular mission has a refurbished Dragon. It has been flown before on CRS-4, so it's a pre-flown Dragon, and that is a pretty big deal too. We have done pieces and components basically previously that we flew before. We have flown them again on another Dragon, but this is the first time when we fly actually the hull, the structure of Dragon, and the majority of the components again. So that lines up well with our quest to reuse and reusability, and overall, in the long term, lowering the costs and access to space.
And can you tell me a little bit about what goes behind the scenes to make all this possible from launch to landing? Yeah,
that's a lot. Well, first of all, when the rocket comes here from Texas, so it's been tested as a stage 1 and stage 2 separately in Texas, and then Dragon has seen a lot of tests in Hawthorne at the same time. So by the time everything is here in Florida and gets put together, those pieces have been extensively tested and shown that they're flight ready. There's also lots of review on data, on build records, and on qualification and certification documents to make sure that we actually, have the right tools and the right components on the spacecraft. And then on top of that, you have mission control and launch control, and the actual work to get the rocket out. That's always exciting, and a lot of people are required to get the rocket up and going in a couple of days. And then when Dragon is actually flying, it takes about 3 days to get up to the station. During those 3 days, there's mission control is going to be active and guiding and controlling Dragon in coordination with NASA. And after that, when it docks to the station, it's going to be a little bit quieter. And then the mission control wakes up again just before re-entry. The astronauts close the door after they fill it up again, basically, for the re-entry. And then they're disconnected from the station and do a re-entry burn, and then land it in the Pacific, where a boat from us waits and picks it up and brings it to the harbor, and then we hand the cargo over to NASA again, and that completes the cycle.
Well, thank you for being with us today.
Absolutely.
And Mike and Tori, back to you.
Okay, thank you very much, Josh. We're at T-minus 14 minutes, 17 seconds, and counting for a liftoff today at 5:07 and 38 seconds p.m. Eastern Time. You're watching the crowd at the Banana Creek viewing site here at Kennedy Space Center, preparing for launch just minutes away. Chris Edelin and his team of flight controllers and Mission Control Houston and the crew aboard the International Space Station also eagerly awaiting this. We had some interesting facts we wanted to pass on about the space station, which is the destination for the rocket on the pad. The International Space Station has 32,898 cubic feet of pressurized volume and weighs 900,000 pounds, providing more livable room than a conventional 6-bedroom house.
And the United States solar array surface area is 38,400 square feet. That's large enough to cover 8 basketball courts.
Crews have eaten about 27,000 meals since the very first expedition in 2000, and about 7 tons of supplies are required to support a crew of 3 for about 6 months.
The International Space Station travels an equivalent distance to the moon and back in about 1 day.
And a year of International Space Station operations with 6 crew operating 365 days a year equals 52,560 crew hours. That's a lot of time.
We would like to welcome those of you just joining us here at NASA's Kennedy Space Center in Florida. The SpaceX Falcon 9 rocket and Dragon spacecraft are poised to lift off on the 100th launch ever from Launch Pad 39A. Launch is scheduled for an instantaneous launch window at 5:07 and 38 seconds p.m. Eastern Daylight Time. Dragon is filled with almost 6,000 pounds of experiments and supplies for the International Space Station and its crew.
Weather is looking great. For those of you who are just joining us, the launch weather officer, Mike McAleenan, has upgraded his forecast to 90% go, and with only slightly under 12 minutes remaining in the countdown and nothing popping up on the radar, we don't anticipate there being any weather issues for today. Here is the current weather forecast. At the time of liftoff, winds expected to be 10 to 15 miles per hour from the east-southeast and a temperature of 82 degrees. The concerns were anvil clouds, cumulus clouds, and potential flight-through precipitation. Many of those concerns we had in our previous launch attempt on Thursday. They are not a concern today. Everything remains in good shape.
The terminal countdown begins at T-minus 10 minutes, at which point all systems are autonomous.
And as we make our way through the launch countdown at T-minus 2 minutes, the Air Force Range Control Officer will confirm the physical safety of the launch and landing areas along with the Eastern Range.
So 1 minute before launch, the flight computer begins final pre-launch checks.
And after polling Mission Control in Houston, Texas, and the launch team at SpaceX Mission Control in Hawthorne, California, SpaceX Launch Director Mike Taylor will give a final go for launch at T-minus 45 seconds.
And at about 18 seconds before liftoff, the launch pad's water deluge system, dubbed Niagara, is activated. It suppresses acoustic waves that radiate from the engine plumes to counter the effect of vibration on the rocket. Rainbird's FireX deluge system maximum flow is over 600,000 gallons per minute.
At 3 seconds before launch, the 9 Merlin engines of the first stage are commanded to ignite, and the Falcon 9 uses triethyl aluminum triethylborane. It's easier to call it TTEB to ignite the 9 Merlin engines. TTEB is pyrophoric, which ignites spontaneously on contact with air and lights all 9 engines. Some other rockets use electric spark ignition rather than this chemical starter.
At T-minus 0, the rocket computer commands the launch mount to release the vehicle for flight, and Falcon 9 lifts off, putting over 1.7 million pounds of thrust, more than 747 jets at full power.
So that's what we could expect here to be occurring within about the next 9 minutes. We're at T-minus 9 minutes, 14 seconds, and counting.
Part of the science going up on this mission is sponsored by the Center for the Advancement of Science in Space that operates the United States National Laboratory. Let's take a look at one of the investigations in particular that has the potential to impact life here on Earth.
Hundreds of thousands of people die in the world every year from organophosphate poisoning. Crystals are a symmetric collection of molecules. So every next molecule in the crystal sits in exactly the same orientation and in the correct symmetry. It's ordered. By growing crystals on the space station, we hope to grow better, more uniform crystals that we cannot grow on Earth. Once we get protein structure, we can design better, faster acting antidotes that can be used against pesticide and nerve agent poisoning. It's very exciting to send my research to space. We should keep pushing the frontiers of science.
We're at T-minus 6 minutes, 46 seconds and counting, and from now until liftoff, we are monitoring the countdown net, which is the primary circuit used by SpaceX launch team during the terminal count. It's been very quiet. There's not a whole lot of conversation. Everything is going according to plan. The latest milestone is that Falcon 9 engine chill has occurred prior to Dragon going to internal power. Dragon is now on internal power. The engines are chilled in order to condition them for the fuel at the time of ignition. Tori?
So after launch, SpaceX ascent commentary is performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute, 5 seconds after liftoff, Falcon 9 will reach supersonic speed. It'll pass through the area of maximum dynamic pressure, or max Q, about 10 seconds later, which is the point when mechanical stress on the rocket reaches its peak because of the rocket's velocity and the resistance created by the atmosphere.
Around 2 minutes, 23 seconds into the flight, the 9 Merlin engines will sequentially shut down. You'll hear the call for MECO, which is main engine cutoff. The first stage will perform a boost back burn in about 20 seconds, heading back to nearby Cape Canaveral Air Force Station. Landing Zone 1. We'll show you the landing on NASA TV at about 7.5 minutes after launch, accompanied by the sonic boom just before landing. So about 3 seconds after MECO, the first and second stages will separate.
7 seconds after the separation, the second stage's single Merlin vacuum engine will ignite to begin a 7-minute burn that will bring Dragon into low Earth orbit. The engine produces 210,000 pounds of thrust. 33 seconds after the second stage ignition, Dragon's protective nose cone, which covers Dragon's berthing mechanism, will be jettisoned.
At the 9-minute, 5-second mark after launch, the second stage engines cut off, SECO. 1 minute later, at a mission elapsed time of 10:05, Dragon separates from the Falcon's 9 second stage engines, and seconds later, Dragon will reach its preliminary orbit.
Dragon will then deploy its solar arrays about 12 minutes into the flight and begin a carefully choreographed series of Draco thruster firings to reach the space station. We're at T-minus 3 minutes, 53 seconds and counting. Everything is still proceeding according to plan. Eastern Range communication checks have been conducted. Everything is working well. The strong back that you see to the left of the Falcon 9 rocket has begun to be retracted ever so slightly, contrary to launches that SpaceX performed at their launch pad, Space Launch Complex 40. This strong back will remain close to the rocket until T0, when it will rapidly fly down and away from the rocket as the rocket flies up.
Go bleed verification. Strongback lowers ended. Strongback's at 88.5 degrees.
GNC announced S2 TVC motion nominal. GNC confirms TVC motion nominal.
Stage 1 locks, let's close it out.
SpaceX has performed a thrust vector control movement of the second stage single Merlin engine, and that went well. 2 minutes, 26 seconds away from launch. At T-minus 2 minutes, we'll be standing by for the range control officer to verify the eastern range is go, no go for launch and first stage landing. The Falcon 9 rocket is on internal power. Everything is proceeding normally. Weather is go. The SpaceX launch team is working no technical issues at this time. T-minus 1 minute, 30 seconds and counting. Standing by for verification that the autonomous flight termination system.
Ready for launch.
And we have confirmation.
Ready for launch.
AFTS is ready for launch. T-minus 1 minute and counting.
VC and DC verify F9 and Dragon are in startup.
F9 is in startup. Dragon is in startup.
Falcon 9 and Dragon are in startup.
Stage 2 is pressing for flight.
Flight computer is...
LD, verify go for launch. Go for launch.
Launch Director Mike Taylor giving a go for launch. Terminal count coming up at T-minus 30 seconds.
30.
Standing by for the pad deluge water system activation at T-minus 18 seconds.
T-minus 20.
Stage 1 locks, pressing for flight.
T-minus 10.
5, 4, 3, 2, 1. And liftoff. The 100th liftoff from Launch Pad 39A as Falcon and Dragon take flight to the International Space Station.
First stage propulsion nominal. Stage 1 propellant utilization active.
Falcon power and telemetry nominal.
Everything going according to plan. Falcon is on target for its rendezvous with the International Space Station. 1 minute into flight. Falcon 9 is going transonic at this time, standing by for maximum dynamic pressure. About 1 minute away from the first stage engine cutoff and the begin of the boost back burn.
MVac chill started.
NASA television will be showing both the second stage carrying Dragon to orbit and portions of the return of the Falcon 9 first stage engine to landing zone 1 at nearby Cape Canaveral Air Force Station. Less than 30 seconds away from MECO, main engine cutoff.
We have MECO 1.
And we have
Stage
MECO 1
separation
as
initiated.
planned.
Stage separation confirmed.
You can see the stage separation. First stage departing, the second stage engine
And
igniting.
back ignition confirmed.
Stage 1 boost back burn has started.
Stage 2 on the left, stage 1 on the right. Falcon 9 first stage heading back toward Earth. Second stage continuing on its way to the International Space Station. The nose cone protecting Dragon will be jettisoned in 5 seconds.
Stage 2 propulsion nominal.
Stage 1 boost back burn shut down.
And as planned, the first stage boost back burn has shut down. 3 minutes 35 seconds into flight. And we're looking at the first stage making its return on the left of the NASA television screen. Falcon 9 second stage engine continues to burn.
Acquisition of signal in Bermuda.
Second stage will continue to burn for another 5 minutes, carrying the Dragon spacecraft into its preliminary orbit. In about 2 minutes, the first stage entry burn will begin. That's a burn of about 14 seconds, bringing the Falcon 9 first stage engine back toward Cape Canaveral Air Force Station. Second stage engine performance continues to be good. 4 minutes 45 seconds into flight.
Second stage continues to follow the nominal trajectory to orbit.
Acquisition in New Hampshire.
SpaceX New Hampshire tracking site now tracking the travels of the second stage as the first stage continues its descent. About 45 seconds away from the first stage entry burn. Second stage continues to perform normally. 5 minutes, 45 seconds into flight.
Stage 1 entry burn starting.
And you can see the stage 1 entry burn underway. Everything continues to go well. Stage 2, carrying the Dragon spacecraft
Stage
to
1
orbit.
entry burn shutdown.
And we have shutdown as planned. 6 minutes, 30 seconds into the flight.
Stage 1 AFTS has saved.
Stage 1 is transonic.
Stage 1 is flying back toward
Stage
Earth.
1 landing burn starting.
Landing burn is starting for Stage 1. 7 minutes, 15 seconds into flight. Everything continues well with the flight of the second stage in Dragon. For those in the area, there will be a loud sonic boom that will occur right about the time of landing, which is expected. The length of time that the sonic boom took to reach Earth.
Stage 1 landing legs deploying.
Landing legs have deployed. And the first stage is back, just miles away from its launch point.
Stage 1 engines have shut down.
Stage 1 engines have shut down.
LZ-1, the Falcon has landed. Landing operators proceed with initial safing per procedure 11.100, section 3 on LZ-1 net.
Everything going according to plan. 8 minutes into flight. About a minute away from second stage engine cutoff.
Stage 2 propulsion remains nominal.
Eight minutes, 30 seconds into the flight, and about 30 seconds away from the second stage engine cutoff. That'll be followed about a minute later by the Dragon spacecraft separation.
OSM boosters landed.
Stage 2 AFTS has saved.
Standing by for engine cutoff.
SECO 1.
And SECO 1, second stage engine cutoff.
Good initial orbit.
Engineers report a good initial orbit. Standing by for Dragon separation in about 30 seconds. Stage 2 making its way on a trajectory toward the International Space Station at 51.6 degrees inclination to the equator. Stage 1 is back on Earth.
Acquisition of signal in Newfoundland.
Standing by for spacecraft separation.
Dragon deployment confirmed.
And a good spacecraft separation. Dragon makes its way toward the space station. Next major milestone is the deploy of its solar arrays. 10 minutes, 40 seconds after launch. "11 minutes, 51 seconds after the launch of Falcon, the Dragon spacecraft is flying free. The next major milestone is its deployment of its solar arrays. needed to continue to power the vessel on its way toward the International Space Station, and a planned rendezvous on Monday. SpaceX Mission Control in Hawthorne, California, following all the activity today. (13 minutes 45 seconds after launch, standing by for confirmation of solar array
Awesome
deployment.
signal at New Hampshire.
And we see one of the solar arrays extended. And the other solar array beginning to unfurl. Everything appears to be going normally. Okay, got your...
So as Dragon unfurls its solar wings, the spacecraft continues its journey to the International Space Station. Dragon will arrive on station on Monday. NASA television coverage will begin at 8:30 a.m. for an expected capture at about 10 a.m.
And that will conclude our coverage today of the launch of Falcon 9 and Dragon. For more information on the SpaceX CRS-11 mission, please visit www.nasa.gov/SpaceX. And for information about its destination, the International Space Station, visit www.nasa.gov/station.
So please tune in for the post-launch news conference on NASA television at 6:30 p.m. this evening. Thank you for joining us, and we'll leave you with a replay of today's launch.
Standing by for the pad deluge water system activation at T-minus 18 seconds.
T-minus 20.
Stage 1 locks, pressing play.
T-minus 10.
5, 4, 3, 2, 1. And liftoff. The 100th liftoff from Launch Pad 39A as Falcon and Dragon take flight to the international.
T-minus 10.
5, 4, 3, 2, 1. And liftoff. The 100th liftoff from Launch Pad 39A as Falcon and Dragon take flight to the International Space Station.
Stage 1 propellant utilization active. Falcon power and telemetry nominal.
Everything going according to plan.